Okay, I'm super excited. I got my new water testing pens here. I have the digital pH meter and then the Tds and Ec meter. This is total dissolved solids and electrical conductivity meter. And I'm just testing these things together because they're always used together. They go together like peanut butter and jelly. So I got my aquaponics system here, and we really have been neglecting it because our old water testing pens are junk and they broke pretty easily. So let's open these up. And let's have a look here, a little operation manual and warranty thing there. Okay, and so let's have a look. Now this is a little bit concerning. Okay, that looks like a I'm not too sure what that is. It looks like it might be salt, perhaps dried salt. Yeah.
Looks like it's been used.
It looks like this particular item's been used. I was wondering if it might have been battery acid, but we'll go ahead and check to see if there's a battery issue up here. Looking at the battery compartment, the batteries look fine. I see that there's no plastic protector on the batteries, so the batteries may have come drained. Also looks like as though there's some salt on the inside here. First thing I notice is that there's a hole here and there's exposed electronics, so we cannot drop this pen in the water. If we accidentally drop this pen in the water will flush the electronics and ruin the unit, so that's a bit concerning. Okay, but we see that the battery does appear to work, which is good. Okay, and the water's dumping right now, so we can check. Can we see how it's 0? I don't know if you can zoom in on that. Reading a pH of about 5.8, 5.9. It looks very good. It doesn't jump around a whole lot. It's the whole time it keeps moving, but it's between 5.8 and 5.9, which is very consistent. I like the fact that it's reading to 2 decimal points. My previous pen would only read to 1 decimal point, and it was a lot more shifty. This is actually very precise. It looks very reliable. It seems like it's settled in on about 5.9 or 5.92. And again, the fact that it's measuring pH to the 100th place is really exciting. I like that a lot. Okay, and as soon as we pull it out, it goes back to 0, so it's a smart meter. It knows that when it's out of water. This is actually way better than my last pH pen. The last pH pen that I bought was $99 and didn't work nearly as good as this, and that's not a joke. This is very impressive. I'm absolutely completely shocked at how good this works. Look at that. It's stable on the 100th place at 5.96, which incidentally is way too acidic. Our fish are gonna not be happy in something that's that. And so I've tested it 3 times now, and the test is very responsive, and each time it's within 1/10 of a pH of the actual, so it's very precise and very accurate. Very good. Let's go see how our other system's doing. Wow, we're definitely way too acidic here. We're at 5.10 and dropping. Well, I'm surprised our fish haven't started dying off yet. At a pH of 5, they're going to start dying if we don't make the system more alkaline soon. Seems to have settled in. Move it around a little bit. So right at about 5. We remove it. It rises up and then realizes it's out of water. Very smart meter, very accurate. And then it goes right back to the same reading. So again, very precise, very accurate. Great pen. I'm really excited. This works so much better than my last pen. This is really something to be excited about. So I'm just going to dry it off a little bit, turn it off, and we'll put it back in its meter. Super cool. So this is my prior pH pen, the Eco Tester, and it's the pH 1. I also had the updated model pH 2, which pretty much looks identical. And this pen here was close to $100. I believe it was $89 plus tax, and the newer one was $95 plus tax. And the cool thing about this is that you can actually drop it in the water and they float, and it's waterproof. And that's the only negative thing I can say about this one is it's not waterproof. If you drop this in the water, it will fry the electronics. But look how good this one is compared to it. Considering the retail, this retails for about $20 or something. This is like 5 times the cost. Okay, well, when we turn these on, first thing that we notice is that this tester over here only goes to the tens place. Okay, and we put them in the water, and look how quickly this one figures out. It goes to the hundreds, and it settles in very quickly as to where the pH is supposed to be. Okay, this one over here is only to the tens, and it's at 8, 7, 6, 5, and what I've found with this expensive tester over here is that it doesn't make up its mind. It just continually, it's like a countdown. We'll leave it in the water for, 5-10 minutes, and it'll eventually work its way down to wherever it needs to be. But you see how this is reading alkaline at 8.8 and now 8.1? Okay, but we know for a fact that this system is very acidic. Okay, we just know because these systems always tend to go acidic. And we see over here that this pH meter is accurately reading the acidity of the system at a pH of 5, or maybe 4.99 or 4.5. But it reads it right away. If we pull them out of the water, we see that this pen, dry them off. This pen doesn't change significantly. This one before, anyways, realized it was out of the water. It's not realizing it this time, but that's okay. Put it back in, and instantly this one goes back to the correct pH. This one still hasn't made up its mind, 7.4, 7.3. So we can see that this one is essentially worthless, which is why we gave up on measuring the pH of our system, because this was absolutely worthless, $100 and completely worthless. This one, only around 20 bucks, and it measures it up to the 100th place, and it's super responsive, accurate, and precise, very effective. I could not be happier. This is a great tool. The only thing that would make it better was if it was waterproof. All right, let's take a look at the total dissolved solids. This is going to give you a lot of information about your water hardness. Okay, so let's see here. This looks good. And battery component looks good. Oh, see a little bit right there? That might have been some battery leakage. I don't know. Again, there's no protective slip, so when that happens, sometimes the battery can end up drained or whatnot. But let's see if it works. It's okay. Oh, I'm putting it on backwards. Sorry. Okay, yeah, let's see here. Okay, so the battery is pretty good. Let's have a look. So we're reading 669 parts per million. And you see the meter rising, that's because the system is dumping right now, and it's probably bringing more solids in as the system's dumping. Goes back to 0 as soon as it's removed. Let's check over here. Wow, look at the difference in parts per million. Wow, my gosh. That's 1557, 1558, 1559 parts per million. And oh, I forgot the temperature, yeah. So it shows the temperature, so it's 23 degrees Celsius. Let's come back over here. And 23, 24 degrees Celsius and 680 parts per million. So you can see it definitely accurately picks up the difference in total dissolved solids between the two systems, and the temperature is pretty good as well. That's impressive. All right. Now we're going to turn this off. Just like so. And then we're going to go check this against our reverse osmosis filter and our filtered water in the house. So it's really important that after you use these, you rinse them off and clean them. But what we're going to do now is we're going to check the pH and the conductivity of our reverse osmosis water. Okay, and let's bring this right over here. And let's see here. So the temperature reading is at 26, which is definitely 27 warmer here than inside. Now we're getting 30 parts per million in a reverse osmosis system. Ideally, we would get 0. 0 water is perfectly distilled reverse osmosis. But we noticed that it's reading at 27 degrees Celsius, whereas outside it was reading at 23, because it's obviously warmer in here. Okay, so if we pull it out, it goes to 0. Okay, put it in, instantly reads back at 27 and 30 parts per million. It's a very responsive meter. This is a very good meter. Okay, and then let's see how we're looking with our pH meter. Ideally, we'd like this around 7 plus. And it's just not. Okay. So a lot of times RO water is a little bit acidic, but wow, I'm frankly shocked to see it so acidic. Yeah, it could be time to change our filter if it's that acidic, but still yet, that's definitely way too acidic. Way too acidic. That's no good. Not happy with that. Okay, so we see what's going on there. Now by comparison, we rinse these off and then test tap water. I'm expecting that the parts per million should be dramatically higher in this. So we turn this on, okay, 0, pull it back so you can see a little bit. Okay, and then putting it into tap water, we see we're all the way up at like 260, 259 parts per million. So definitely our RO system is working pretty good. It's a big difference between 258 and 30 for our filtration system. Okay. Good. And let's go ahead and check the pH here. Look at that, isn't that interesting? The tap water is not nearly as acidic as the RO. That doesn't really surprise me because a lot of times the minerals that the RO filters out are what help to keep the water alkaline to begin with. And in a perfect world, the water would be, clear and alkaline, but that doesn't surprise me. Yeah, no, so the tap water is 6.8, 6.85. Much more neutral than the RO. Again, RO is usually just slightly acidic. Okay, but now we're going to dump this and we're going to test it against the Menehune water, which is reverse osmosis and ozonated. Should probably be a little bit more clear. Oh, you know what? Let's use the cold water. That way we can see the temperature difference, right? Now this, because it's commercial water, should be even more pure than our system. Let's have a look here. So when we test this, pull back a little bit. Okay, at 0, we'll put it in here. And look at that, yeah, 4 parts per million versus our RO system. And look, it's noting at 17 or 16 degrees Celsius, so the temperature gauge is very responsive and accurate. Yeah, and look, 3 parts per million, okay. That's pretty darn good. I think the only reason it's not completely 0 is that Menehune water's been sitting in that bottle in our garage for maybe a month or two. So that's pretty darn good. Okay. So yeah, very responsive, works right away. Tap water is at what, 260 parts per million. The RO system is 30 parts per million, and Menehune's at 3 parts per million. And then of course the aquaponic system is up above 1,000 as we'd expect. Okay, and let's just go ahead and check the pH of the Menehune water. Look at that. That's still going down. Yeah, RO's usually a little acidic, but not quite as acidic as our system. And the reason is likely because this water's ozonated, which, as I stir it up, and it's going down. Now it's coming back up again, so. Okay. 5.8, 5.9, yeah, RO's a little bit acidic. But certainly we can see that the temperature and the purity of it is right on point, actually. Alright, so we added in some hydrated lime into the system to make it a little bit more alkaline and bring up the pH. So you can go ahead and recheck it now. Let's see. So last time we were in the 5s. And right now we're reading about 6.63. .657. So we're doing pretty good here. So we went from low 5s to high 4s, right up to about 6.5. So we're doing a lot better over here. And let's see. We did a water change over here and put in a little bit of hydrated lime. And over here, looks like we're rocking a 682, which is a lot better.